Math 3, Classwork 1.3. First, determine if each relation is a function or not. So when you look at the graphs like numbers 1 and 3, it's an issue of the vertical line test. If any vertical line can cross the graph more than one time, then it is not a function. So I'm going to draw some vertical lines. And whoa, it only took one vertical line to see that it crosses the graph more than once for a single vertical line. So it is not a function. And over here for number 3, if I draw a vertical line, it only crosses it once there. If I try to draw a line right where the piecewise function changes functions, the filled in point is a point on this vertical line, but the not filled in point does not represent a point, so it does pass the vertical line test. And I can continue. There's not even a single point there. It actually does not cross any points. So this one is a function. For a table of values, you need any input to only have a single output. So input 12 does not occur a second time. It only has one output of 5. 7 occurs only once. It has an output of 9. So this is a function. Maybe your question is, what would have to be there for it to not be a function? And what that could be is, let's say 7 shows up again, and the y value is not 9 for its output. Let's say it's 10. If this had been part of that table, then it would not be a function. So every input can only go to one output, not more than one. For solving each equation, I have written out work in the answers, and I can talk you through that written out work. For problem number 4, you want to realize that there is a single variable here. And so your job is to isolate it on the one side of the equation that it is existing on. So I'm looking for the weakest operation. Know that there is an understood parentheses anytime a root is drawn. So that means that the subtraction under the root is as strong as a parentheses. It is very strong. It is stronger than the root itself. So the plus 6 that is outside the square root is the weakest operation. So I subtract 6 from both sides to get 2, and then I stop and I look at what is now the weakest operation. So now the cube root is weakest because other than that, everything is understood to be in a parentheses. So the opposite of cube root is to cube both sides of the equation. And so 2 cubed is 2 multiplied 3 times, and you're going to get 8. And now all that's left is what was in the parentheses. So I no longer need those parentheses. And now I have a multiplication by 2 and a subtraction by 1. The weakest operation is now that subtraction. So I am going to add 1 to both sides and then divide by 2, and I get a solution. For problem number 5, again, notice that this left side of the equation has 1x, so my job is to isolate it. And I can see that the addition that is not in a parentheses is weakest, so I subtract 8 from both sides first. Then I stop and I look at where I'm at. I have multiplication by 3. I have addition in a parentheses, so it's strong, and an exponent. So between multiplication, parentheses, and exponent, multiplication is the weakest operation. So that is the first thing that I will undo at that point. And I undo multiplication by dividing. Then I'm going to stop after I divide by 3 and take a look at what I have. The parentheses is stronger than the exponent 3. So the first thing I'm going to do is undo the exponent 3 by doing the cube root of both sides. And the cube root of 27 is asking what number, so I'll put n for number, what number, when multiplied 3 times, is equal to 27. And this is why you want to know your number patterns. So that number is 3. 3 multiplied 3 times makes 27. Now I want to mention that when you take a square root of both sides of the equation, you have to do plus or minus. But it's an even root. It's an understood 2 index. When the index is odd, like 3 for the cube root, you do not need a plus or minus, and we're going to continue to talk about that throughout the course, including later on today. We'll see why plus or minus is needed when we take a square root. And we'll look more into the cube root issue not needing it at a later time. So we find ourselves here, and all that's left is to subtract 4, and then we are done. For numbers 6 through 8, I'm dealing with function notation, and I want to see that the name of the function f tells me which of these functions to work with. Whatever is in the parentheses right after the name of the function is going to be what substitutes into the variable that the name of the function has after it. So what that basically means is I'm going to take the expression x plus 4, and I'm going to substitute positive 10 for the x, and that will give me 14. For number 7, I want to look at the named function. It is g, so I'm going to focus here on g. And it has a plus b in parentheses there. So that means everywhere that the g of x has an x variable, I have to substitute a plus b. But very important, g of x says that whatever the variable is, x, it is multiplied by 5. The whole thing is multiplied by 5, and then I subtract 12. So when you substitute into an expression, it's best to put a parentheses where the variable is that you're substituting into. So the x will be replaced with a plus b. And now you can see that we need a distributive property for multiplication over addition to see that this is 5a plus 5b minus 12. And I cannot bring any of these terms together because we have variable a, variable b, and just a constant term. They can't be brought together. Number 8 is saying what is 4 times h of negative 2. So I'm going to write 4 big old times, and then I look for function h, and the variable is x. So everywhere that that x shows up, I'm going to substitute in negative 2. And the best way to substitute is read the equation, and every time I say x, put parentheses. So h of x is x squared, so parentheses squared, plus 4 times x, 4 times parentheses, minus 7. And then I'm going to substitute negative 2 into each of those parentheses where the x was. Right here, I have negative 2 completely squared. That means I am dealing with negative 2 times negative 2. 2 negatives make a positive, and that is a 4. This 4 is coming from that one. Then I have plus 4 times negative 2. So positive 4 times negative 2 makes negative 8. And then I have a minus 7. And then we're almost done. A little bit of arithmetic. So 4 times negative 11, and I end up getting negative 44. Now for the crux of the lesson today, and this is a tough one. So you're going to have to look through the video a couple of times or ask for more help, and I'm going to keep talking about it in class because it is one of the more complicated issues to cope with. So the parabola does not pass the horizontal line test. And I've been saying a little bit here and there that y equals x squared and y equals the square root of x are almost inverses, but they're not full inverses. Y equals x squared is a nice looking parabola. Y equals root x is only half of a parabola. It is a sideways parabola opening to the right, but only the upper half. So what I want you to realize is that the right side of my parabola y equals x squared creates the inverse function root x. And if you draw these two together on one grid, you will see that they reflect each other over the line y equals x.